The yellow area is bounded by two functions. One of them is 3 sine x, shown in red, and the other one is by 4 cos x, which is shown here in blue. And the area is also bounded by the x-axis. So to calculate this area, we're going to have to do it in two sections. And the sections could be split at A, where the two functions meet together at the intersection. And to find out what A is, we'll need to equate those two functions so we can find the intersection. And this will be easily done if we remember that sine x over cos x gives us a tan x. So I'd like to rearrange this equation so that it looks like tan x. We write sine x over cos x is equal to 4 on 3. And that means that tan x is equal to 4 on 3. And so the x value will be 10 to the negative 1, 4 on 3, which gives me 0.927. So our A value will therefore be 0.927 here. And pi on 2 will be 1.570. So that's the same thing as pi on 2. Now, I've worked it out algebraically by equating those two, but you can also go straight to the calculator, put into the graphics calculator these two functions and find the intersection, and you'll find that it is 0.927. So to find this area of the yellow shaded function, we're going to divide this into two areas, that green one over here and that blue one over here. So the total area will be the area bounded by the red function from 0 to 0.927, which is 3 sine x, bounded by the x-axis, plus the area from 0.927 to 1.57 of the function which is 4 cos x. And so we integrate this. Sine becomes minus 3 cos x, and we take it from 0 to 0.927, and 4 cos x becomes 4 sine x, again from 0.927 to 1.57. And continuing just to substitute this, firstly substituting 0.927 and 0, and then we continue substituting for that 4 sine x here with values of 1.57 and 0.927. This working out on the calculator just give me 1.19929. I'll just go a little bit further, plus 0.8007, and if we add these two together, we will get 1.99999, which is almost 2 square units, as this is area.